We're going to classify a triangle in the coordinate plane. So we have our triangle here, and none of them are horizontal or vertical. It would be great if they were, then I could just count them and know what the length of a side was. But I'm going to have to use the distance formula 3 times. For this red side, PO, for this blue side, PQ, and for this green side, OQ. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1. And notice that I put the template down already so that all I have to do is fill in the proper spots. Okay, so the OP are these two ordered pairs here, and this is x2 and x1, so that is -1 and 0. And then here for the y2 and y1, that's 2 and 0. Right? So -1 minus 0 is -1 squared plus 2 squared. Now, if you end up with a negative, you have to put parentheses around it because there is a difference in -1 in parentheses is answer and no parentheses answer. It will mess it up if you don't have parentheses on that negative. So -1 squared is +1. -1 times -1 is 1, and 2 squared is 4, so I have the square root of 5. If I put that into the calculator, I'm going to get approximately 2.2 using the square root button. Okay, now on the next one, PQ. All right, so here are my ordered pairs for P and Q. That's where I got them. X2 and X1 is 6 and -1. Y2 and Y1 is 3 and 2. When I add the opposite here, I get 7 squared plus 3 minus 2 is 1 squared. So that is 49 plus 1, which is the square root of 50. If you put that into your calculator to get the square root of 50, you're going to get approximately 7.1, and it has been rounded off to the nearest tenth. And then for the green one here, we have the x2 and x1, which is 6 and 0, and then y2 and y1, which is 3 and 0. So I have the square root of 6 squared plus 3 squared, which is 36 plus 9, which is a square root of 45. If you put that into the calculator, you're going to get approximately 6.7, rounded off to the nearest tenth. What we see when we're trying to classify it to see is it acute, well, if it is isosceles or, and it wanted me to classify by the side, so it's either isosceles, scaling, or equilateral. And since all the numbers are different, 2.2, 7.1, and 6.7, I know that this is going to be scaling. All right, now they're asking me if it is a right triangle. Let's go to the slopes. You can use the slope formula, but it's much easier if you've got a picture just to count it. Start at the bottom, count up till you get even to the top point. So rise 1, rise 2, I'm rising 2, and I'm running 1 right. Run to the left, so that's a -1. I have a slope of -2. For the blue one, I'm rising 1, so the rise is 1, and I'm running 1, 2, 3, 4, 5, 6, 7. So that's 1/7 for that slope. And for the green one, I'm rising 1, 2, 3. And I am running 1, 2, 3, 4, 5, 6. 3/6 reduces to 1/2 when I divide them both by 3. So I see I've got a -2 and a 1/2. So what I know is that those are negated reciprocals. And if they're negated reciprocals, then that means that is a right triangle. So OP is perpendicular to OQ. So that means it is a right triangle. So it's a scaling right triangle.